I'm here with Photon, the roving robot that's going to take pictures and video at Faire, North Carolina. Welcome to Hack-A-Week.
So Photon needs a drivetrain, and what I'm going to use for his drivetrain, I think it's a he, is what's left of the old all-terrain robot that has a Cduino on it, which is an Arduino cloned microcontroller. I've still got the main board here from a Roomba robot that's got the H-bridge on it that I tapped into to drive the motors. And I may use a couple different other Arduinos. I've got, let's see, I got a Uno here that is in one of the talking robots. That's going to get pilfered for the text-to-speech module. The Leonardo is in here as yet unused. I had plans for that, but I may use that. Or I may just use the other Uno I got. But anyway, Uno, however you want to pronounce it, you know what I mean. So let's get this torn apart and then figure out how we're going to reconfigure it so Photon can drive around.
Let's take a look at a quickie drawing I did of what I have in mind for this robot. The Roomba wheels will be here. I didn't put the casters on, but they would ride right there and right there. A battery fore and aft, and a big tube section in the middle. I was going to do that in 4-inch PVC, but I've changed my mind. I'm going to use one of those 8-inch concrete forms that you can buy at the hardware store. And then all the way around that, here and here, I will have some bump sensors, basically just an arrangement on a spring with a screw and a contact, so that if it bumps into something, it makes contact, and then that activates part of the code that tells it to stop, back up, turn a little, and continue going. And then up here, some sort of a roundish head, 2 cameras, which will look like eyeballs. I'll put the ping sensor where a nose would be. And in the mouth area, probably the speaker will mount in there, and some LEDs that light up and modulate with the speech. And then up on the very top, there will be 2 smartphones. One will be streaming video on its video camera through my provider's video connection to the web, just streaming to Ustream, basically, Verizon. And so then the smartphone here will be transmitting video via Wi-Fi, an Android app that I found, and I can have that transmitting back to my booth at Faire, where people can watch and see just what the robot is seeing out there on the floor as it interacts with people. And then way up on the top above it all, perhaps maybe even pointed down on a really high mast, a GoPro camera recording the overall scene as it happens. And these 2 cameras down here, these 2 video cameras, will be recording video all the time that it's out. And I'll have to get a couple of big old SD cards for that, I suppose. So those casters, I picked these up today down at the hardware store. Now let's see how they size up next to the Roomba wheel as far as height and all that goes. Looks like that's going to work out pretty good, because I'll be mounting this to something on the bottom of a board very similar to this board that's here on the bench. I'll cut it out in a big circle and mount all the stuff up to that. That'll serve as the base. So as far as this height goes, these 2 motors will go on a mounting block, and then of course this will have to be the same height from the ground, so it looks like that's going to work out great. So now it's time to get the base built and then get these motors mounted up on the base, on the left and right sides of the base, and then the 2 casters will go fore and aft. Once we get that done, we'll level everything out with the adjustability built into the casters right here, so that everything is touching the ground equally. Then we'll start mounting up the upright pillar section and move on from there.
This is a left motor and a right motor, or maybe it's a left motor and a right motor. Anyway, they came from 2 different sides of the Roomba, and I'm going to mount them in my new robot
like this so that they're symmetrical with each other, and the wheels will be right next to each other like this. So an arrangement like this on one side and another one on the other side, and then they can move around and tank steer. But I need to do something to get these two to mount together. So what I did was took these mounts that I have on all four of these motors here, and I made them all the same by bolting them all together with these 3 bolts, and then I cleaned up around the edges and made them all, you know, the same dimensions, and then drilled 2 new holes right here. They're full of holes right now, but there's 2 new holes here that will be for the bolts that will hold them to a central mounting point. That central mounting point will be a piece of 3/4 inch box section aluminum stock. So I'll mount them to that and cut about a 3-inch piece of that, and then I can mount that to the base of the robot. And when I do, I can mount 1 bolt here with a hole, solid hole, and then the other hole up here I'll make elongated so that I can give it a little bit of toe in to make sure that it tracks straight and true, because if I get one to one side, it'll tend to wander to the left or right. I don't want that. So next up is to cut a couple of pieces of this material and then bolt the motors together on it. Okay, let's bolt these together. There we go. 2 sets of wheels ready to mount up on the base. So this is the base of the robot. This is what everything will mount to. There will be a column right here. Cardboard tube about 8 inches in diameter and about 4 or 5 feet high, I think. And up on the top of that is where I'll mount all the camera equipment, the head and everything, some sensors on the side, bump sensors. I'll have a few bump sensors around the perimeter of this base. The wheels will mount here on the base. I've already set up some holes in these. This front hole is a little bit bigger than the back one, which will allow me to twist the motors just a bit to make sure that they are lined up exactly correct. So I can mount those up now with these bolts here and just run them through there into the aluminum and put a nut on the bottom. Simple as that. So let's do that now. Big washers on top so that the wood doesn't squish under the torque of the screw. Just flip everything over here and put on one of these nuts. These are nylocks. These have a little nylon insert that keeps them tight. Just happened to have some of those around, which was really convenient. Let's get that tightened up. Okay, both of the motor sets are mounted up on the base. And now we can make sure that they're parallel with each other. And we do that just by pretty much measuring it. Pretty simple. Make sure that they aren't too out of parallel. And then we'll tighten up these bolts and then we'll move on to the casters front and rear. Well, I ran into a little problem here with the wheels that need to go on here. When you look at from the edge here, the height of, well, from the floor to the height of the deck, if I want this wheel to be that same height, well, it doesn't quite go all the way through the board now, does it? So I had to come up with a solution for that, and my solution was to just simply put another piece of wood right here on the bottom. Pretty simple procedure, and then drill it with a flat bottom bit and recess the hole, and then I can put this in, and there's room for a nut on the top, no problem. So we'll go ahead and mount all that up and get everything leveled out now. There we go, caster wheels all mounted up, and the nuts are in place and tightened up, and they come out kind of flush with the surface, which is nice, kind of a happy accident there. They are set up so that there's a little bit of play up and down right here, and that's okay because that ensures that these drive wheels are making good contact with the surface. So that's about it. Now we can get the microcontroller and the H-bridge on there as they are, basically. I'll hook the ping sensor back up and get a battery power to it, and we can drive it around and see how it does. I fitted the body to it. It's a big cardboard tube used for pouring concrete pillars, and it can be torn apart after the concrete is poured. So that just sits on those 4 pieces of 2x4 that you saw earlier. So the battery's pretty charged up here. I've got everything on board and wired up. Figaro's ready to check it out. Let's turn it on and see how it functions. Looks like it steers just a little bit, oh, quite a bit, to the right. Doesn't really track perfectly straight. We can figure that out later with alignment on the wheels. Maybe change the PWM on the speed of the motors. That will probably take care of that. But it's functional. Looks like it does a pretty good job of driving around.
Well, we've got a pretty good start on Photon here. We've got the base built, the motors are functional, we know that the ping sensor is working, and the code for the old Roverbot works just fine. Next episode we will be putting on the upright column, start work on the bump sensors so that it can avoid banging into people too many times, and we'll start working on the head. Eventually it'll get the text-to-speech module put in. That'll be fun, so it can speak with people. So this will go on for probably at least 3 or 4 more episodes until it's all finished. So stay tuned, and until next time.
I'm here in the kitchen with Photon, the prototype robot I'll be taking to Maker Faire this year. And as the batteries run low, we'll get started on this hack.